comes on, but I want to get this started. Were you guys able, was this the picture you saw?
Yeah.
Okay, so you had to figure out the amplitude. Now, remember, set it up like this. You always want to pull out your A, and you want to pull out your B.
Good morning. Today is Monday, February 13th, and it is an A day. All classes.
So you had always start with your A and your B. Your amplitude is always positive. Can you see this go from 1 to 4 to 3? It's at the 3. That's where your amplitude is. From here to here. From the lowest, from the resting point to the highest or the lowest. It's always from the resting point. It's like the crest of a curve. You know, like a wave or a curve or something. The frequency tells you how many full cycles in 2 pi. So you could count this. This is 2 pi. So your sine curve goes like this. There's 1. Then it goes 2. There's 2. So you can see your frequency. Your period is how long does it take to complete 1 full cycle. So 1 full cycle is the at pi, or we say 2 pi over b. Know this formula. Sometimes it's easier in degrees. If you did 2 and 360, how much for 1? Well, 360 divided by 2. Okay? Just so that you're getting this part. Amplitudes and periods, how did these go for you? This one, when they do it over the x, just pull out the 1/2. This is b. B is 1/2. This is a. This is b. So if I do, and think of it all logically, if I do half of, here's my sine curve. If I do half of this curve, this has to go from 0 to 360 to 2 pi. Half of my curve. So how long is it going to take me to do the other half? Another 2 pi. So 4 pi. So when you do the period and you do this, don't cut this 2 pi in half. Keep, change, flip. It's 4 pi. Okay, everybody see that? Don't give me half of that. Because if you do half your curve in 360, you need another 360 to do the other half. Think of it logically. This is my frequency pi. Just work with your frequency. Your period becomes 2. Don't forget, when we do your drawing, we're in radians. So a radian is about, I guess, 1.5, is it? 1.5 is a radian? 60? Somewhere around there. So you can kind of estimate that. Here's a negative. A negative is a reflection. So be careful of the reflection. Amplitudes are always positive. That's why we say absolute value. The reflection just causes the sine curve, instead of to go up, it causes it to go down. That's all it does. Just reflect it over the x-axis. It's not next to the x, it's next to the y. Are we getting this part? Okay, everybody can find amplitudes, periods, and frequencies. That's the most important part. Okay, if you had to do a curve from here, this dark curve is your original curve, like your foregraph, your parent graph. This is a cosine curve. How do I know that that's a cosine curve?
Right over
It's where?
It's like right over the...
It's over it. It doesn't start at the 0. Good, Bram. It starts up. Cosine starts up here. Sine starts down here. Remember, they're in 90-degree shift. So the sine is going to start at the 0. The cosine is going to start at the 1. So what did it do from here to here? There's amplitude change. So your amplitude went from a 1 to a 2. Did it keep the same period? 1 curve in 2 pi? Yep, 1 curve in 2 pi. So that still is 1. Okay? And because the amplitude changes like this, in terms of transformations, we call this a vertical stretch by a factor of 2, using our transformation names that we've always used. If you're going to change your frequency, this is going to be a horizontal. If it's going to shrink it in like this, and you're going to get a lot of these little guys, then that's going to be a shrink, a horizontal shrink. A stretch would be like the 1/2 one. That would be a stretch. It stretched it out. So I gave you that separate sheet of transformations just because the trig ones, again, kind of like the log ones, they looked a little different. The trig ones look a little different. Stop me if you have any questions. It was moving along here pretty good.
I don't know how you, oh, never mind.
What?
For 31, I just didn't know like why you put pi in it, but.
That is a shift. We didn't get to a shift yet. I didn't do the shifts with you, but we'll do that today. If you see this here, this came out to 4 pi. So in the middle is 2 pi. This is 1 pi, 2 pi, 3 pi, 4 pi. So if this is my core graph, my parent, I'm working off of a sine curve. But I shifted it over. Instead of starting here, I shifted it. This is the same as a cosine curve that negates. If you gave me a cosine that negates there, that's also like a cosine curve. But all I wanted you to see was that it shifted this way. This is called a phase shift. We didn't get to that. I didn't want to throw that in there yet. So I apologize that you saw one here. This one, here's my curve, my dark one. This is a cosine curve. So I notice I got a lot of these things now. So my amplitude stayed the same. I'm still with the 1. But if I start here and I go 1, 2, I changed my frequency to 2. I now have 2 curves in 2 pi. So the period for one curve is pi. So what I did was I took this like an accordion and I squished it in. I shrunk the period, technically. I went from 2 pi to 1 pi. So you have a horizontal shrink. It's kind of like just taking your hands and going like this. It's called a horizontal shrink by a factor of 1/2. Okay? I took half the period. This is really what I wanted you to get out of this lesson, since we like are barely getting through graphing them, but so that you could kind of see what you're looking at before you actually start graphing it. This guy started here, 1, 2, 3, 4. So he was at a regular sine curve, and this is a translation. We didn't exactly get to that on Friday, when we were here Friday, for a quick day. But what this happens is this. Here's the point you want to look at. This point went from here to here. How far did it move? How far did it go? Up 2. That's my plus 2. That's my vertical shift. If I did this, this took my regular parabola, and where did it bring it? Up 2. It does the same thing with a sine and a cosine curve. So instead of starting here, this is my resting point. This is my resting line. I might have called this a midline. Does anybody remember hearing midline? Maybe? Sometimes they call it a midline. I call it the resting line, but sometimes they call it a midline. So your resting line up here is here. All you got to do is look from one point to another. Make it corresponding points. I like to go right off the origin because it's easier to see, because it's right along your axes, and you can kind of count the spaces. So here it goes here, up 2. That's your shift. Now, my curve itself, this says 4 pi under here. This says 4 pi. Here's my cutoff to 2 pi. How much of my curve originally did I do in 2 pi? See, this said 4 pi. I wrote over it. It said 4 pi. That means they gave you the thing we just did before. The period is 4 pi to complete this curve. But here's where your 2 pi is. So you only did half of your curve in 2 pi. They shouldn't have done that from off the dark one. They should have made it a regular sine and then stretched it, but they didn't. So here is your frequency. This is your B. It kept the same one up here. So that's where this 1/2 comes from. And that's called a horizontal stretch. You took your curve, your sine curve, you stretched it out. Your period is now twice the size. Isn't your period for the sine curve 2 pi? Now your period for the sine curve is 4 pi. I disagree with them doing it this way, but because that's not really your parent graph, but they probably just did it off of any graph. I didn't write the directions down. They did it off of the dark graph. So this gives you a vertical shift, and this also has a horizontal stretch in it. Okay. This guy had a phase shift. If you didn't get this, I'm not concerned. But if you think about your sine and your cosine curves, didn't we say that they're 90 degrees apart? If we shifted them over 90 degrees, they would be the same curve, right? If I put my sine curve here, and I shifted this to the right 90 degrees, I moved everything here, then this would have gone somewhere, I don't know, somewhere over here. It would have been I don't know. It should come out to be your cosine curve. They should come out to be the same curve. And I'm not concerned if you don't get a phase shift right now, because we didn't do phase shifts. So don't worry about the phase shifts. My biggest thing is trying to get you just to get the basic curve down. This is also a phase shift, so if you didn't do this one, don't worry about it. We'll do this one another time.
We didn't have that.
You didn't have that one?
No, it's
Not 42.
Went to 43?
Yeah, we had 42.
And for some reason, I'm like off this board, but were you guys able to do these? This is a phase shift. Don't worry about this one. Don't worry about 49. Okay. Go to 43.
Yeah, why do you have like 0, 0, pi over 2, 3? Like,
Don't worry about that.
oh,
Don't worry about that part. Were you just able to sketch the graphs?
yeah,
Yeah.
yeah.
Okay, we didn't do a phase shift, so we didn't go over the where does it start, where does it end business. I just gave you the directions, probably said 5 me to zeros. I didn't give you that part. Don't worry about that. My biggest thing is, can you sketch these? The only thing that changed from your sine curve was your amplitude. So everything stayed here, and an easy way to do this, when you look at your sine curve, just take this and multiply everybody by 3. I did mention that a little bit on Friday, but in that half an hour we went through so much.
So you just put vertical stretch, you didn't put like by a factor.
By a factor of
You
3.
know,
God bless you.
bless you.
This one took your cosine curve and shrunk it. It's a vertical shrink by a factor of 1/4. Graham had a good point. This guy is the same as 1/2 x. My amplitude stays the same, but my frequency changed.
Yeah, I don't, why is that graph like that? Oh, because
First of all, it's off because of the computer, the word press. Everything kind of like moved here, so I think this kind of got a little bit weird looking. But what this says is I only want half my curve. Here's my original cosine curve. Here's 2 pi. So I only want half of this curve now. Half of my curve goes right up to here. I want to take this curve and stretch it out. Okay, so here's an easy way to graph this. Remember we said find the period, right? If I do half my curve in 2 pi, it takes me another 2 pi to get a complete cycle, right? So my period is 4 pi. Agree? Okay, to get the quadrants, anybody remember how we get the quadrants to map this out? We took the period and did what? Divided by 4, because how many of those little quadrants do we have to go through? 4. So therefore, every pi. So I would set this up like this. If this is pi over 2, this is pi. If this is this is 2 pi. Just stay with me for a minute. This is 3 pi. This is 4 pi. Agree? I'm just going to have to go every pi now. I need 4 pi to make this whole curve. So my cosine says 1, 0, negative 1, 0, 1. Let's go 1, go to pi, 0, negative 1, 0, 1. In 2 pi, isn't this half of my curve? The hardest part is where should we graph this? So you're going to take your period, no matter what the period is, and divide it into your 4 quadrants. And then you're going to go through this cycle. You can eyeball this as well. The cosine curve is a little harder to get than the sine curve because the sine curve is just a mountain. So if you're doing a sine curve from here to 2 pi, it just makes a mountain. Like it makes like a little mountain. But the cosine curve starts at the top. So you're only getting down to here for half your curve. So if you considered stretching that out, and it has to end at 2 pi, somewhere right at the pi, it's going to cross through, right? If I did this, I know it's going to end at 2 pi. Here's my 90, my pi, here's my 2 pi. I know half my curve is going to be here and end here. Isn't it going to cross through here? There's half of my curve. Whichever way you're comfortable with sketching this. Okay. Don't worry about 49. 49 is a phase shift. And we're gonna work on that. Not yet. If we ever have a full day, we'll work on that. That's also a phase shift. This guy, it might be easier if you put this at the end here. There's your vertical shift up one. Your period, again, they're in radians. So you can actually graph this also in radians. That's what you do when you put pi out there. Because pi is 3.14, so pi over 2 is 1.57. So you can kind of judge your radians by that. We don't do those too often, but you see those. These guys, I'm sorry, did I give you these? No, good. These are phase shifts. Okay. All right. Yeah.